Hi, this is Math 1650 and this video is over section 6.2. In this section, we're going to continue to look at the normal distribution, but this is going to be a non-standard normal distribution. So the non-standard normal distribution shape is still a bell curve. The area under the curve is still equal to 1 or 100% probability. The mean does not equal 0, and the standard deviation is not necessarily 1. And basically with this, our z-score is not going to equal our x-score. So we have to find our z-score for each x-score that we are interested in. And we're going to use it using the z-score formula that we've seen already. X minus the mean over the standard deviation. Alright, so let's look at IQ test. Mean is 100, standard deviation is 15. We want to know the probability of having an IQ score over 130. Okay, so let's see what z equals for 130. 130 minus 100 over 15 is 30 over 15, which equals 2. So this is a z-score of 2, and we are looking to the right. So we want to find the probability of x greater than 130, which is the same thing as the probability of z greater than 2, which is going to be equal to, and we gotta do this on StatDisk. And just like before, we go analysis, probability distribution, normal distribution, and it opens it out. Put in the z value of 2, and we get greater than probability of greater than to the right 0.02275 or 2.3%. That is our probability there. Right, so the only difference from 6.1 is we use the mean standard deviation to find a z-score. Then it's all the same. So let's say we want to know the probability between 85 and 130. So again, we want the probability of x less than 130 and the probability of x less than 85. That means we have to find the probability of z less than 2. That's for the 130, because we already found out the z-score for that is 2. And the probability of z less than, and now we got to figure out what the 8.5 is. So the z-score 85 minus the mean over the standard deviation, negative 15 over 15, which is negative 1. So z-score less than negative 1. It's negative 1 to 2. We are looking for this probability. And so we'll put these values in. We already have the 130 in. We just then grab it. So left is 0.97725. That's for z-score of 2, z-score negative 1. Left is 0.15866 when we subtract. We get 0.81859. Alright, so the probability then of an x-score being between 85 and 130 is equal to 81.9%. Okay. Now, we're going backwards on this. We want to know what IQ is at the 20th percentile. So 20% to the left and 80% to the right. Okay, what is the z-score, and ultimately what is the x-score that goes with that? So we start with StatDisk, and we put in 20% to the right, or I'm sorry, to the left, and we find that z-score. So p of 20 equals negative, oh, hold on, do it this way. Just write the z-score equals negative 0.84162. Now we gotta find the x-score. Now remember, our z-score equals x minus the mean. I'm gonna use symbols here. X minus the mean over standard deviation. I really kind of screwed up my symbols here. There we go. Nope, I don't even have it up yet. Alright, so we're going to start with the standard deviation formula. We're going to solve it for x. So z times the standard deviation equals x minus u. Then add the mean over, get z times standard deviation plus the mean equals x. So we have what z is. Z is negative 0.84162. We have the standard deviation is 15, and we have the mean is 100. When we calculate this, and you have to be careful, that is a negative z-score, so you have to put the negative there. 0.84162 times 15 plus 100 is an 87.4 IQ. Alright, let's do some more. Find the probability less than 70. This is for x being less than 70, and it gives the mean as 75, and standard deviation is 3. So again, first we find the z-score. So 75 minus 70 over 3 is 5 over 3, which is about 1.6667. Now, it's good when you put this into StatDisk to do as many as you can. Now we are finding this less than that. So we are going to do it to the left. So find the area to the left. So again, z-score, when you have repeating numbers like this, just put in as many as really you can. And then take the area to the left here. So we get 95.2%. Oh, I just realized something. That's supposed to be a negative. So, if I write this again. So 0.4779, so 0.048. Let me show you where I made the mistake. I should do 70 minus 75. That makes that negative. So that's negative. Put that in, you get 0.048 or 4.8%. So we're actually on this side. So I'm going to the left of that. Alright, so find the probability of greater than 120. So z is 120 minus 100 over 15. So 20 over 15, which is going to be very similar, 1.3 repeating. Alright, so this one's out here, and we want greater than it, so we want to the right. About as many as you can. And we get to the right 0.09121 or 9.1%. And then the third one here, between 210 and 235. It's a mean of 200 and standard deviation of 20. So we have to find two z-scores here. 235 minus 200 over 20, and 210 minus 200 over 20. So bottom one gives us 10 over 20, which is 0.5. Top one gives us 35 over 20, which is 7 over 4. So it's 1.75. So we want probability of z less than 1.75 and a probability of z less than 0.5. So two different values here. Both on the side, 0.05, 1.75. Again, we're looking for that middle region. So start with the higher one, 1.75. We get a left probability of 0.95994, and then 0.5 is the probability of 0.69146. When we subtract them, we get 0.268, and so it's about 26.8%. Okay. So now we want to find the x-scores. Now this is going backwards. We'll have the area, find the z-score, then we find the x-score. So the area to the left, we'll do both of these at the same time. Kind of area to the left here is given. And for the second one, the area to the left here is 1 minus the area to the right. Okay, so 0.8321 and 0.22. We're going to find the z-score for each of these. 0.8321, and we get the z-score is 0.9625, and then 0.22. We get a z-score of negative 0.77219. Alright, so now let's find the x-score. This would be a good formula to write down. X is standard deviation times the z-score plus the mean. So this would be standard deviation is 15 times 0.8321 plus 100. Oh, sorry, not 0.8321. I grabbed the wrong number. 0.9625. That's your z-score. Okay, I got 114.44. And then for the bottom one, x is equal to 20 is your standard deviation times your z-score, which is negative 0.77219 plus 200. And get 184.56. This is the x score that would have 22% below and 78% above. And for the top one, this is the x score that would have 83.21 below, and whatever the opposite of that is above. Which is 0.1679. Alright. Let's get into a couple of applications. The Tall Clubs International has a requirement that women must be at least 70 inches tall. Given that women have normally distributed heights with a mean of 63.8 inches and a standard deviation of 2.6 inches, find the percentage of women who satisfy this height requirement. Alright, so we gotta find the z-score. The mean is 70, or the x value is gonna be 70. I'll write this out. X is 70, mean is 63.8, standard deviation is 2.6. So 70 minus 63.8 over 2.6. I get 2.38. And we want to know percentage of women, not the best normal distribution, but I do my best in drawing, that are above this value. So this is your 2.7 or 2.38. We want to know the area to the right. Alright. So probability of x greater than 70 and find the 2.38, and we get to the right 0.00866, which is equal to 0.87%, so less than 1%. Alright. When designing aircraft cabins, what ceiling height will allow 95% of men to stand without bumping their heads? Men's heights are normally distributed with a mean of 69.5 inches and a standard deviation of 2.4. Alright, so this is one where we gotta work backwards. We want this number to be higher than 95% of the men. So 95% is to the left. 0.95, and our z-score is 1.64485. Okay, now we want to find the x-score. Is the mean or the standard deviation times the z-score plus the mean. So 2.4 times 1.64485 plus the 69.5. And I get 73.45. Right, so it has to be about 74 inches. So one last problem. Some educators argue that all students are served better if they are separated into groups according to their abilities. Assume that students are to be separated into a group with IQ scores in the bottom 30%, the second group in the middle 40%, and a third group in the top 30%. We want to know what IQ scores will separate these groups, given a mean of 100 and a standard deviation of 15. Right, so we'll kind of do this twice here. We're looking at 30%, 40%, and 30%. So we want to know these z-scores. Z-score for the area to the left being equal to 0.3, and this z-score will have the area to the left equaling 0.7, the 30 and the 40 put together. Oops, wrong thing. Alright, so 0.3. Okay, first z-score is negative 0.5244. And then the second z-score, 0.7, is a positive 0.5244. And now we gotta find the x-scores. Again, x is equal to the standard deviation times the z-score plus the mean. So 15 times a negative 0.5244 plus 100. We are at 92.13. And this next one, the higher number, would be equaling 15 times 0.5244 plus 100. We're at 107.866. Oops, I didn't switch off of this. Okay, so that's what I have. Alright, so this value 92.13 breaks up the 30% to the 40%, and the 107 breaks up the 40% to the highest 30%. Alright, so in the next video, we'll still talk about stuff with the normal distribution, but we're going to switch away a little bit from some of the ways we're doing it right now. But this is still, I think, some of the most important things is what we do on these first couple of chapters in this or first couple sections in this chapter. All right, I'll see you in the next video. Bye.